Hello, I'm Phil, and today I'm going to talk about my first outdoor experiences with the M5Tough Garden. And the second topic, I'll talk about how I've extended the M5Tough Garden hardware towards Microsoft FarmBeats compatibility. So in preparing to use the M5Tough box in the garden, I aim to try and fit all the additional electronics inside the lower portion of the M5Tough box, and including the Port B expansion unit. But there wasn't enough room, so I had to bring the ports from the M5Tough out of the box, and this requires providing labels on the cables so they're easy to identify, and it also requires putting the additional electronics in another watertight container. So those sensors and the battery for everything, they all need protection. And just before a storm occurred, I was able to prepare for everything to go inside this box. And the box provides both sun protection and rain protection. And the sensors also have some protection. So there are small transparent caps that fit on the soil moisture sensor and also on the pump. Now the pump, in addition, has a soil moisture sensor, but all the electronics is exposed on both, and we need to protect those. Inside the box, all the other sensors and electronics are all labeled and mounted. So we're still using a Lego baseboard, and we're using Grove cables, but we're extending those so we can easily locate the additional sensors, like the soil moisture and pump can be located at a distance away. And this is my map for this project. And I've done a couple of smaller projects, but the one I want to look at today is the sun soil project. And it's still a unit test. And in this test, I want to look at providing those sensors which were not on the Microsoft FarmBeats kit, and that includes the soil temperature probe and the sunlight. So I want to add those for FarmBeats compatibility. So the soil temperature uses a small chip from Dallas Instruments, and it's already waterproof, but the connectors are not. And the Grove sun sensor measures the visible light intensity, the UV radiation, and IR radiation intensity. And I need to provide communications to send these soil temperature and sunlight measurements from the Seeeduino Nano to the M5Tough computer. And the communications I'll be using is a serial port. And in the M5Tough, I need to set up variables for each of these additional measurements. And the results will be sent to a Windows PC using the UIFlow blocky commands for printing. And it uses the serial port to the Windows PC to achieve this. And all this is in the benefit for STEM education and farming education. And instead of using a turnkey system, you're able to look at the nuts and bolts, write down and build up your own farm kit or FarmBeats compatible system. So here's the project. I'll go through what the objectives, the hardware, the software, show you some of the results and talk about some of the issues and give you my references. So here's the hardware and the costs for the various components. So the only M5 stack component is the M5Tough. And here I'm using port C. And you can see how it can be configured in software using for the receive port 14 and for transmit port 13. And since I'm using Grove cables, I have to switch the receive and the transmit on either the M5Tough or the Seeeduino computer. From Seed, I'm using the Seeeduino Nano, quite a low-cost computer, and it also has a Grove shield that allows an additional 6 ports to be connected. The Nano already has a Grove connection, but it only connects to the I2C port. And I am using this, in this case, to the Grove sunlight sensor. So the only additional sensor is the 1-wire temperature sensor, and it has a Grove connection, and it also comes from Seed. And those 2 connectors and the link between the Nano and the M5Tough are all using Grove cables. Alternatively, you could use the sunlight and temperature probe sensor if you already have the smart agricultural kit from Seed Studio. So this is how it's built up. We take the M5Tough. We have to remove the screws and have a look inside. And that allows us to get access to the Grove ports. And they're all color-coded. Red for the I2C, which is port A. And next to that is the black port, which is port B, which is a GPI connector. And the next one is the blue port, which is port C. And that's the one we'll be using here. And the last port is a green one. And it's used for the RS485 and solar power connections. And this is the connection from port C. It goes to the USB Grove connection on the Nano carrier, and that connects to the Nano USB pins. So we're also adding here the Grove soil moisture or soil temperature probe. And to the I2C port on the Nano, we add the Grove sunlight sensor. And that is all, the M5Tough is connected to a Windows PC, and I'm using the Arduino serial monitor to have a look at all the data that I'm collecting. And here's the software. So there's 2 pieces of software. One is in the M5Tough, and there's the name of the program, the Sunsoil. It's written in the UIFlow IDE on the Windows PC, and it's doing a bit of text processing. So it's looking at the data streams that come in from the Nano and setting up data parameters for those values. And I'm adding additional labels for feedback. The other thing is that I'm adding a small user interface on the screen of the M5Tough. And this is what it looks like. with the various labels. So all I'm doing here is just reporting on the soil temperature measurements and the sunlight measurements. And the other piece of software goes inside the Seeeduino Nano computer. And I'm using the Arduino IDE, and the program is already written for you from Dallas Instruments. So if you import that and go to the examples in the IDE, you can see the program. All you have to do is just make sure that the right port has been selected. And in this case, I'm using port 2 on the, or D2 on the Nano computer. And I'm using 4 libraries. And the extra library here is the SI114X library. And here's the, all the work is done in this main loop after setting up. So all I'm doing is getting the soil temperature probe measurements and the measurements from the sun sensor, and then sending those via the serial port with a header for each of the measurements. And here are the results. This is what it looks like on a Windows PC on the serial comms monitor. So you can see it's measuring the ultraviolet or the visible light, the infrared, and the ultraviolet radiation intensity, and also the soil temperature. And the issues I've got, I'm corrupting the screen. So while it's a bit of a nuisance on this program, I won't be showing these measurements, and hopefully when they're integrated, the additional sensors, we won't get corruption on the screen. And also, I can't convert the text into numbers. And this is one of the limitations of the UIFlow software. And I need to use the decode block. So there are some strange things going on in the UIFlow process for text processing. And here are some of my references. So you can go to the M5 website if you're interested in the M5Tough computer. And for the other sensors and the Seeeduino Nano, go to the Seeeduino website. Thank you. This is my first extension to the M5Tough Garden, and it adds additional sensors to make it Microsoft FarmBeats compliant. And it does this by adding 2 sensors. This sensor here is the soil temperature probe, and it goes in to a small computer that acts as a router. And the small computer is a Seeeduino Nano, which is Arduino Nano compatible. And in addition to the soil temperature probe, there's also the Grove sun sensor, which is this one here. And both sensors plug in to the small Nano computer via Grove connections. And there's also a Grove wire to the M5Tough computer over here. So what we've done, we've removed the M5Tough from its case. And if we have a look at the other side, you'll notice the ports on the M5Tough. The red one is the I2C port, or the A port, next to the GPIO port, the black one, which is the B port. And we're now connecting to the port C, which is the serial port, with a blue connection. So what we've done, we've extended the M5Tough Garden by adding 2 more ports, and we've got another 5 growth ports left over, so we can add additional sensors if we need to.